assigned for this section, like as your homework, it is optional. It is extra practice. I did not tell first hour that. I told them that it was due. So tell first hour that it's not due anymore. Okay. We have four different methods to solve quadratic equations. This one says solve by factoring. What's the first step to factoring anything? GCF. What's my GCF here? 2. So I'm really going to take out a 2 and then divide it off. So I'm really just going to divide both sides by 2. I get 3x squared minus 11x minus 4 is equal to 0.
If we do the x method first,
that's fine. Change it? No, you'll get the same answer. Yeah, what Ava just asked is if I didn't pull out a GCF, would I still be fine? Yeah, she would get the same answer. She would just have a little bit more work to do with the factoring. Now I have a trinomial. I use the x method to factor. Two numbers that multiply to 3 times negative 4, so negative 12, and add to negative 11. Huh? Negative 12 and 1, perfect. Okay, can I just say my answer is x minus 12x plus 1? No, why not, Brooke? Because the a is not 1, so I have to regroup and then, or I have to rewrite my middle term and then regroup. So 3x squared minus 12x plus 1x minus 4 is equal to 0. Group my first two. What's the GCF out of my first two? 3x. I'm left with x minus 4. My second group is already at x minus 4, but I still have to take something out. I'm going to take out a 1. So a positive 1, x minus 4. Second to last step, x minus 4, that's my matching parentheses, so that's part of my answer, or my factored expression. The 3x plus 1, those GCFs that I took out, is my other answer. That is all something we could have done last unit. The new thing is, what should I do to each of these pieces?
What happens to the GCF that we took out?
I divided it off. Set them equal to 0. Set each one equal to 0. Perfect. So x minus 4 is equal to 0, and 3x plus 1 equals 0. So Musab, I took out a 2, and then 0 divided by 2 is just 0. So I divided it off. So we get x equals 4. And if I subtract 1, divide by 3, I get negative 1/3. And that is my answer. So that's one method, is factoring.
Drop the GCS.
Yeah, I just divided it off. So technically, there's like a either divide by 2 or pull out a 2 and then divide it off. However you want to think about it. Any other questions on that one? Okay, hopefully that method we should probably know the best out of all of them. Completing the square is probably the one that we're not as comfortable with. So on your test, I'll have a question for each type. You will have to complete the square, you will have to factor, and you'll have to do the square root method. So you have to know each one. This one's completing the square. Step 1 to completing the square is you make sure a is 1. A is 1 here, so I'm good. If this was like a 2, I would want to divide everything by 2. You force a to be 1. The second step, does anyone remember step 2? Yeah, add 31. We move the constant over. Move over c. So x squared minus 6x is equal to 31 if I add 31 to both sides. Step 3, I need to find my special number. Does anyone remember the part that you have to memorize to find that special number? b over 2 squared. If you do not have this part memorized, you will not be able to complete the square, and you'll get a 0 on this problem. You won't be able to do it. You have to memorize this. b over 2 squared. So let's find b over 2 squared. So what's b? Negative 6. So negative 6 over 2 squared, that's negative 3 squared, that's 9. So I'm going to take that 9, and I'm going to add it to both sides. That's my special number. On the right, I just need to combine like terms. So 31 plus 9, 40. On the left, this will always factor into x plus or minus a number squared. Does anyone remember what my number is? -3. It's the number that I squared in my b over 2 squared. It's b over 2. You don't have to memorize that part. We could have just done the x method, two numbers that multiplied positive 9 and add -6 is -3 and -3. But you do have to write it like this or you'll be stuck. So we do have to write it as a factor squared. That was the whole point of completing the square. We wanted something squared is equal to a number. Now we have something squared by itself. How do I undo the squared part? Square root. Boom, boom. Square root of x minus 3 squared is x minus 3. Square root of 40 is plus or minus. Don't forget that. And then let's break this up. What perfect square factor fits into 40? 4. Okay. Whew. I heard 5, and 5 does fit. But let's pull out a 4. 4 and 10. What's the square root of 4? 2. So 2 root 10. Last step, I'm just going to add that 3 over. Where should it go? In front of the plus or minus. Perfect. So 3 plus or minus 2 root 10. If this root 10 was not here, I would actually do 3 plus 2 and 3 minus 2 and get 2 numbers. But since there's a root there, I'm stuck. And that's my final answer. Questions on that one?
Would we do the plus or the minus?
Both. 2 answers always. 2 answers. Any other questions on that one? Okay, so we're going to talk briefly about when to use each method. We're going to do one example of each method, and then rest of the time will be yours to start your review guide. So we talked about this a little bit on Friday, but we can factor when b squared minus 4ac is 0 or a perfect square. What do we call b squared minus 4ac? I heard it. Starts with a D. Discriminant, perfect. So remember this piece right here determines how many solutions, what type they are, real or imaginary, and it also determines if this is factorable. My recommendation, don't find the discriminant every time. Just try to factor it, and if it can factor, cool, and if it can't, move on to your next method. Okay, so this one, let's just try to factor it and see what happens. X method, 2 numbers that multiply to 12, add to -8. Go ahead.
No, I just want to ask, is it b squared minus 4ac the discriminant or only the -4ac?
The whole thing is the discriminant. What 2 numbers do I get here?
6.
Yeah, 6 and 2 both have to be negative. And in this case, my A is 1. So I can just put those numbers into my factors. X minus 6, X minus 2. Now what? Zero product property. Set both of those equal to 0. Solve, we get x equals 6 and x equals 2. So that's factoring. I would just try factoring first. It's probably the easiest and the fastest for you. You can for sure know if you want to factor it. If you look at the discriminant, I would just try to factor so you don't waste your time. Musab.
When can you not factor?
If this is not 0 or it's not a perfect square. You can only factor if this is 0 or a perfect square. Or just try the X method. If it works, then factor it. If it doesn't work, then move on.
If it's equal to 0, you mean?
Yes. Okay. Next one, completing the square. Completing the square always works. However, hold on, Musab, I'm getting there. Completing the square always works. However, I would only do it when b is even, because we need that b over 2 squared. If b is odd, and when we divide it by 2, we get a weird fraction, it's going to be weird to complete the square. So I would just recommend only do it when b is even. Okay? Go ahead.
So since it's equal to 0, we can do factoring in that one too.
No, only when the discriminant is equal to 0. Only when b squared minus 4ac is equal to 0. You have to find a, b, and c and then plug it into your discriminant formula. If you have questions over that, I would look at Thursday's lesson.
What would you do if b is odd then?
Different method. You would say, I don't want to complete the square. Let's move on to my next method. Okay? So complete the square always works. Don't do it if b is odd. Just don't. You'll deal with fractions. It'll get you confused. I would just recommend not doing it. But in this case, b is even. It's negative 12. And if we look back at our steps, a is 1. So I move over to step 2. I move over c. I'm going to subtract 8 from both sides. So x squared minus 12x, leave a gap, is equal to negative 8. Step 3, I need my special number. What's the formula for my special number?
B over 2.
B over 2 squared. If you don't have that memorized, highlight it, circle it, put a star on it, write it on a separate sheet of paper. I don't care, but you gotta have that piece memorized. Okay, so this would be negative 12 over 2 squared. So negative 6 squared, which is 36. What should I do with that 36? Add it to both sides. So plus 36 plus 36. On the right, combine like terms. I get 28. On the left, it's always going to factor into x plus or minus a number squared. This number is negative 6. Comes from right here. It is always b over 2. Or x method, two numbers that multiply to 36, add to negative 12, are negative 6 and negative 6. Now I have something squared is equal to a number. How do I undo the square? Square root. Boom, boom. X minus 6 on the left, plus or minus the square root of 28. What perfect square factor goes into 28? 4 and 7. Square root of 4 is 2, so plus or minus 2 root 7. Final step, add the 6. So 6 plus or minus 2 root 7. Again, if this root wasn't here, I would do 6 plus 2 and 6 minus 2 and circle both answers.
When we take the root and do plus or minus, why don't we have to put it before, like in front of the root 4 and the root 7?
Only one is fine because like if you just have one, that means the whole thing is positive or negative. If you put it in front of each, you're still just going to get the whole thing as either positive or negative. You only need it once. If you put 2, it wouldn't change anything. Any other questions? Okay, that's completing the square. Square roots was our next method. We can only do this when there is no linear term. So this one has a pretty strict, it has to be something specific. You have to have either just an x squared or x plus or minus a number squared. You should not be able to say like b is equal to this. There should not be a bx term, okay? So when you have just something like this for your x's, you want to isolate that thing that's being squared. So for this first one, we're going to isolate the x squared. What should I do first? Move over the 24. So 2x squared is equal to negative 24. Okay, now what? Divide by 2, we get x squared is negative 12. And now we're back into something that we just did up here. Something squared is equal to a number. I square root both sides. I get x is equal to plus minus root 12. What perfect square factor fits into it? 4 and 3, and I'm going to stick my negative with the 4. What is the square root of negative 4? 2i. So final answer, 2i, root 3. questions on that one? Next one, so this is the second case where it's like x minus a number squared. Essentially, we're going to do the same thing that we did when we completed the square. Isolate it, take the square root, and then do your plus and minus. So if I need to isolate this x minus 3 squared, what should I move over first? The 32. Okay, so negative x minus 3 squared is equal to negative 32. Now what?
Can I get rid of the negative?
We need to get rid of the negative. So x minus 3 squared is equal to positive 32. Just divide everything by negative 1. Or change the signs. Now I have something squared is equal to a number. What should I do? Square root. Boom, boom. Square root of x minus 3 squared is x minus 3. Square root of 32, 16 and 2 gets you 32. What's the square root of 16? 4, so plus or minus 4 root 2. And then last step is just to add that 3 over. So 3 plus or minus 4 root 2. Be aware, if you forget a plus or minus, you're forgetting half of your answer. So you're going to lose a good chunk of points. It does not, because this is really just like, let's say that x minus 3 is a different variable, y. This is like negative y. And you wouldn't make it negative y again. You know what I'm saying? Great question, though.
Could you not have added the x minus 3 squared to the other side instead of...
We could have, yeah. We could have moved the x minus 3 squared over first, and then it would have been a one step. That's fine. Either way works. Any other questions on that one? We could have divided by negative 1 first, and then move the 32. Okay. Last method. Quadratic formula. It always works. Always. Except for it takes forever, and it's really easy to mess up. So this is like your last resort. We'll talk about the order to check for things at the very end. But for quadratic formula, we need A, B, and C. What's A? 2. What's B? Negative 3. What's C? Negative 20. Then we plug it into our formula. X is equal to negative B. So negative 3. Positive 3. Plus minus. Square root of B squared. Negative 3 squared. This has to go in parentheses. If you try to put that into the calculator without parentheses, your answer is going to be wrong. Okay? Has to go in parentheses. Minus 4 times A, which is 2, times C, which is negative 20. All over 2 times A. 2 times 2. Okay. You are not ever allowed to plug this whole thing into the calculator. You are allowed to plug in one piece of it. What piece? The discriminant, whatever's under the root. So feel free to plug that in.
Why are we not allowed?
You will get the wrong answer every single time. And you won't have work, so you'll get a 0 every single time. So, negative 3 squared is 9. This comes out to 160, so 9 plus 160, 169. You can do that in your head, you can do it in the calculator, but that's really where your calculator usage stops. Unless you're like just simplifying a fraction or something. Okay? What is the square root of 169? 13. So 3 plus or minus 13 over 4. Should I leave my answer like that? No. Why not? Yeah, these are all like terms. I can actually simplify this down the entire way. So we're going to split it up into the plus version and the minus version. So 3 plus 13, 16 over 4, which is 4. 3 minus 13, negative 10 over 4, so negative 5 over 2. Final answer, don't just give me the number. Make sure you put an x equals in front of it. So x equals 4, x equals negative 5 over 2. And that was the last method. But try not to use that unless you absolutely have to. One more thing that I wanted to bring up that I mentioned nearly every day we did this unit. I can ask you to solve quadratic equations in like 4 different ways. I might say find the roots. I might say find the zeros. I might say solve or find the solution. Or I might say find the x-intercepts. They're all the same thing, with the exception of like we can't graph imaginary x-intercepts. So it looks like there's none. They're all the same thing. So if you see any 4 of these words, you're setting your function equal to 0 and solving for x. That also means if we start with a graph and I asked you what are the roots of this equation or function, you can tell me based off the graph. What are your roots here if they're the same as your x-intercept? Yeah, 1 and 3. So you can also say the roots of whatever function this is are x equals 1 and x equals 3. I don't think I make you do that one on the test, but just like key part here, you might see all 4 of these words on your test, and you have to know that they all mean the exact same thing. Okay, questions on that one? Last thing is like your order of what method to use. First method, try to factor if you can. Second method, if you feel good about completing the square, complete the square, especially if b is even or square root. Then do your square root method if you just have something squared, always. Very last option, quadratic formula, last resort. Works every time, but takes forever, and you often mess up on it.
If you tell us to complete the square, will b always be even or square root?
Yes.
Can you tell me the quadratic formula?
Yeah, x is equal to negative b plus minus square root b squared minus 4ac all over 2a. Ava.
Do we ever like have to do the quadratic formula, or
Uh,
can we always choose not to?
I think on your test, I make you do the other 3, but I don't make you do the quadratic formula. But you might have to if the other 3 options aren't an option for you. If you can't factor it, if b is odd and you don't want to deal with fractions and you can't take the square root, then you might have to do the quadratic formula.
I can, or if it's just not possible.
What?
Even if
If it's not possible, you'll have to do the quadratic formula. Any other questions?